Today I'm going to attempt to replace the power supply in a 1541. I realize I'm not reinventing the wheel here. This is by far a well-documented solution. Lots of videos, lots of tutorials out there. In fact, this was inspired by a recent tutorial by Adrian's Digital Basement. You may have seen it. I thought it's such a worthwhile upgrade. Our 1541s draw a lot of power, they draw a lot of heat, and they're quite heavy. And this kind of touches on all those points. So I thought, what the heck? Let's give this a shot. And I've never done a video before, and I thought, well, maybe I'll try to document this and see how it goes. So here we go. So here's my trusty 1541. It was 100% stock at one point. I've made a few modifications, a custom front badge, custom paint job. As you can see, custom LEDs on the back. I have a device ID switch for device ID 8 and 9, and then a parallel port adapter for parallel transfers. On the top, I added this custom decal. And on the bottom here, I've got a speed control access port. So these Alps drives have the trim pot for the speed control is underneath. So having this hole here, I can adjust the speed of the drive if I need to at any point without opening it up. Now, today I'm going to attempt to replace the power supply, as I mentioned. I'm going to use this Meanwell. It's an RD-35A. It is nice and light and very small. In the back here, we see our ports. We've got our AC in here, ground, and then the V2 and the V1. These are our 12 volt and 5 volt respectively, the voltages we need to be able to run the disk drive. So this should do the trick. Now, what I wanted to do before I start tearing everything apart, I want to get an idea of the current load that the 1541 draws. So I've got just a electricity meter here, monitor, and this should give me the wattage. So powered on, right away we get 13.9 volts. So just under 14 volts powering the device on. Sorry, not volts, watts. Now, I'm going to add load. So I'm going to get the drive to start doing something. So I'm just typing in a format command here. Never mind my cheap camera. And we're going to get an idea of the load, the amount of power it requires to do that. So running a format, you can see it jumping up. We're already at 30 watts. So 30.6 watts was the highest here. And that's, again, this is just a standard format. I do have a Jiffy Dust kernel in here. So it should only take a moment to finish. There we go, I'm all done. And we're dropping back down to just over 13 watts now. So let's go ahead and power this off. Okay, now before I get started, I think what I want to do is get the schematics. So I have an idea what I want to do, but I thought, always good to have a diagram to work with here. So go to my trusty computer and print out some schematics. Things look good. All right. Coming along just fine. There we go. Looks good. So I've just recorded the wattages we were seeing under the normal power supply there. So under idle, between 13 and 14, and then 30 watts when we're actually doing something with the drive. So just quick look into schematics. Like I was saying, I do have a pretty good idea just from watching those videos from before what I can do or what I need to do here. But if we quickly look here, so this is the power rail we're looking at, and everything sort of before those VR1, which are the voltage regulators, I should be able to basically just disconnect all of that. So that's where the AC gets turned into DC, and then the voltage regulator converts it to the 5 and 12 volts that we want to see. Okay, so this is part of the video that I wanted to share with you that is not exactly what I would call a tutorial. It's more of a log because I don't have the equipment necessary to properly film while I'm working on it. So I did take some photos while I was working away, and what I'm going to attempt to do here is just sort of illustrate sort of the process. So I've just opened the cap here, and you can see some of the modifications I've already made. Over here we just have a switch hooked up. It's a double pull, double throw switch for device 8 and 9. It also, when it switches, it also changes the LED color, the power LED color. Green is 8, 9 is blue. And here you can see my parallel cable mod. Okay, this is soldered into this chip. The chip can be easily removed, so it was not a big deal to take this out. This is the only the device ID switch that I have to change, and this just comes right off, and then you just unplug all these components, and then it's fine. Okay, so first thing, so now I've removed the board. So there's my 6522 over there for the parallel mod. So the board's been removed, and I've exposed the transformer in here. So this guy has to come out. There's really not much to it. There's basically 4 screws on the bottom, and yeah, I'd say this is probably the majority of the weight in this 1541. When this guy's removed, I'm expecting it to be considerably lighter. Yeah, and to remove the transformer, it's quite easy. It's literally these just 4 screws. They're pretty big, but nothing special about them. Just Phillips screwdriver, that's fine. This will just be careful because it's when it's upside down like this, it's slightly elevated. So this is hanging on to these screws. That last screw is going to kind of pull on. So I just kind of shoved my fingers underneath there to hold it in place, because it's probably a few centimeters there that it'll drop out in. One thing I didn't capture is the transformer. The last thing you need to do to remove it is you need to cut away some wires, and these open the pen here. So these colored, there's orange, blue, these 2 blues and these 2 oranges, they can stay connected. They go to the main board. They feed the voltage to the main board. They can stay attached. What we're interested in is this red, sorry, not the red one. The red one can stay attached as well. So the white
the black and the green. We need to cut these as close as possible to the transformer, because you basically need as much slack, because these are not very long, these wires that come off the main terminal here. So cutting the black, the white, and this is the ground here. So now that I've removed the transformer, I want to get an idea of where to put the Meanwell power supply, how it fits in, making sure that the terminals I can access quite easily and, you know, connect to the inputs. So it has like these screw holes on the side. There's like a little locking one or like a slider, and then there's that one at the top right there. So fastening the power supply to the case, I kind of lined it up to where I have some room in here to work, where I can attach to these terminals. And I marked this hole here on the side of the case, and just used a drill bit and drilled right through. Okay. This is the other side of it. If you're wondering, you know, what size screw this is, or where I got this locking nut, I'll give away my little secret here. These voltage regulators, which we're going to talk about in a minute, they are coming out. We're getting rid of these. So I just simply took these screws out and then used them to lock in the power supply. Now, I've only used one screw here. You're probably best to use at least two. However, these are so light, and when this is nice and tight here, there's no movement whatsoever. And, you know, even moving this case around, it's not going to move at all. You know, you kind of have to reef on it, and then this might start to bend. But for the way I'm going to use it, this is going to be more than enough, more than stable enough to keep that power supply locked in. Okay, so here we have the power supply, and I've attached the necessary cable. So we'll start with the main inputs. So we've got the ground wire that's attached to the case. You'll see that's the green here that gets attached to the ground connector here. We've got our neutral, which is our white connector. This comes in off the main terminal. And then the black. The black is fed into this fuse, which is good, because if you know, if there's a overload or anything like that, that should protect our power supply. And that is then connected to here. Now, to get our 5 volts and 12 volts we need for our main board, I've attached this standard Molex connector. You can get these out of any PC or any computer shop now. I've attached a Y cable. Why? I'll tell you why. Because it gives me both connectors, the female and the male connector. So it is possible if I needed to attach any other accessory in here, I would have another access point. So then this is just attached at 12 volts. Standard is on our yellow, and the 5 volts is our red connector. And both the black is the common here, so that gets plugged into our power supply as such here. If you're wondering, this is a trim pot. I've not played with this at all. I tested the voltages on here with my multimeter. I got 11.8 on the 12 and 5.1 on the 5, which as far as I know is well within range. So I believe adjusting this might zero closer in, but I didn't touch that at all. I just left it as the default. So now we'll take our focus to the main board and look at the changes we need to make here. So these are our 2 voltage regulators. These need to be removed. We're going to tie right into this. our power supply is supplying the 5 and 12 volts we need, so we don't even need these at all. We're just going to connect right to the pins on this. So remove this. These are not too bad. There's a couple of screw holes on the bottom here. So it passed. So these 4 screws need to be removed. Okay. On top of these solder joints here. So you need to remove these as well. These are our grounds where the screws go through, and the 5 volts coming in from the AC or the rectifiers comes in through here and then is converted to, sorry, it's not 5 volts, it's, I think it's 9 and 16, but then it's dropped down to 5 here, and then 12. This is the 12 over here. This is our 5. And that's where we're going to connect into. Okay? And we can basically, once we've disconnected from here, we're no longer talking to, these are the voltage rectifiers, and then the capacitors are somewhere underneath here. So this is the top side with the voltage regulators removed, and I'm going to tie in to these 2 ports on this one and over here on the 12. Just another view of everything removed from the bottom. And here we go. So again, the red is our 5 volts, 12 volts is our yellow. And I've come in through the top, almost like, pretty much the way they Adrian did on his video. Seems like the best way, because what you want to be able to have the same control as you did before, where you could just disconnect the power using this connector. I did think about putting connector here, but again, you know, I wasn't sure how to do it. I could glue something or drill into the board, but then I guess, you know, I didn't want to risk damaging anything, so this seemed like the best solution to do that. Just another view here. I am going to remove these caps because they are no longer needed. I can remove these rectifiers and this connector and some of this other stuff, but I don't think I'm going to bother. These big caps can go just to help with the weight a little bit. And they kind of get in the way sometimes when you're trying to hook things up in here. So here's another view. I've removed the caps, the big caps. I've connected my Molex, just sort of fished it through where the original connector would come through. So it's just a little gap here, a small slot. And we should be good to test this out. Just another shot of it all connected up.
Okay, so this is our smoke test here. I've put the top back on. I put the 6522 in here. I'm just going to turn the power on. I have not reused those 2 wires you see there. Those are my device ID switch wires, and I like this. I got the green power light, and then I got the drive activity light comes on. So I think the smoke test is good, and we're ready to plug her in. Okay, so I've reassembled the drive. Now I'm going to do initial load test here. Powering on. 7.4. How about that? It's like half. Almost half of what we're getting before. That's significant. And drive reset, that looks good too. I think we're looking good here. So I'm going to do a format. I just switched it to device ID 9. Just to make sure that my device ID switch is running. So we'll run a format here, a load, 17.2. Wow, that's amazing. I think that is success right there. You know, again, a considerable reduction in power. And although I'm not really demonstrating in this, the weight is significantly lower as well. Well, there you have it. I thank you for tuning in. I hope some of you are still awake. I know that was not the most exciting video ever. Maybe you learned something, maybe you didn't. Maybe you've got some comments. Maybe I did something wrong. Maybe I could do something better. I'm always a believer of improvement. So again, this was just for some fun. I thought I would do this. I've always kind of wanted to improve the efficiency of these 1541s. I use my drives a lot. I know there's some modern replacements out there, but I still love the original floppy disk. So and they're great for, you know, converting stuff to digital as well, some of your old floppies. So I use it a lot. Anyway, so this is a great mod for me. I hope maybe it'll inspire somebody else to do the change. It's pretty inexpensive. And, you know, if you've got questions, you want to do this yourself, you want some help doing it, you know, I'm open. I'm happy to help. Again, you know, I appreciate you tuning in and listening and watching, and I had some fun with this. So have a great holiday, and maybe I'll do another video sometime. Thanks.